Jai Hind. Myself Nidhi Singh. I am assistant professor in Electrical and Electronics Engineering Department in Ajay Kumar Garg Engineering College. Today I am going to take a topic from Basic Electrical Engineering. This is the first year subject and the topic is analysis of single phase AC circuit. And in this question I will also discuss the previous year university question papers solution. So the content of this lectures is first we will discuss the AC circuit which is containing resistance only, that is purely resistive circuit. Then we will discuss purely inductive circuit, then purely capacitive, and then we will discuss the combination, that is RL, RC and RLC, that is a series circuit. And in a similar pattern we will discuss the parallel AC circuit. So first we will see AC circuit containing resistance only. So here you can see this is a purely resistive circuit and this is the AC circuit. So voltage equation is Vm sin omega t. So we know that V is equal to IR and the current can be written as I is equal to V by R. So if you put if you substitute the value of V, that is Vm sin omega t, in this equation, you will get this equation, that is Vm by R sin omega t. Now this value, this Vm by R, right? This Vm by R is nothing but a maximum value of maximum current. So this Vm by R can be replaced with Im. You can replace this Vm by R with Im. So here you can write, you will get this equation, current value I is equal to Im sin omega t, right? So if it is written capital I and M, it means it is a value of maximum current. And if it is written with a small letter like small I, small v, it means we are talking about the instantaneous value. So here this I denotes the instantaneous value of current and here small v denotes the instantaneous value of voltage. Now just look at these two equations, the equation of voltage and equation of this current, right? What you can see, Vm sin omega t, Im sin omega t. So what you can see here, that both voltage and current, they both are in same phase. So if you want to draw the phasor, so V and I will be in the same phase. So in purely resistive circuit, voltage and current, they both are in same phase. Now if you want to calculate the power, instantaneous power, so we know that power is equal to V into I. So if you want to find out the instantaneous value, so basically it is the product of voltage and current at that particular instant. So you can write P is equal to Vi, which you have written here. So V you know, Vm sin omega t, and I you know that Im sin omega t. So after mathematical calculation, this will be the final result. This will be the final result. So here you can see that Vm Im by 2, this is a constant part, right? But Vm Im by 2 cos 2 omega t, this is a fluctuating part because of this cos term here. So it has two parts, the constant part and the fluctuating part. Now if you want to find the average power, so average power, if you find the average value of this part will be equal to 0 as cos term is here, but Vm Im by 2 if you integrate for one whole cycle, so you will get the value Vm Im by 2. This is the average value Vm Im by 2, where Vm and Im are the maximum value of voltage and maximum value of current. But if you want to write it in terms of RMS, then Vm by root 2, this is the RMS voltage, and Im by root 2, this is the RMS current. So you can write P is equal to Vi. So if you write P is equal to Vi, so here V and I, M is not written here. It means it denotes, we are writing capital V and we are writing capital I. It means it is denoting the RMS value. It is not necessary that we always mention here RMS, right? Sometimes we can mention, but if it is not mentioned, it is understood that these are the RMS value. So P is equal to V into I, where V and I are the RMS value. So this is the average power. Then next is AC circuit containing pure inductance only. So here in this circuit only inductance is there, voltage equation is this, and if you derive, you will get the value of current as Im sin omega t minus pi by 2. So what you can see here, the voltage equation is Vm sin omega t, but current equation you can see minus pi by 2. What does it mean? It means the current is lagging by 90 degree. So if the circuit is purely inductive, it means current will lag the voltage by 90 degree. So if you want to draw the phasor, so here you have drawn the VL and here you have I. So it is lagging. The current is lagging behind the voltage by 90 degrees. So how you know that this current is lagging, right? If you see, if you go in the clockwise direction, right? If you go in the clockwise direction, so the VL, after VL, the IL will reach here. So it means this I is lagging by 90 degree. Now next, how to find the power, instantaneous power. So we know power is V into I. So substituting the value of V and I, that is omega t minus pi by 2, and calculating, you will get this value, right? This is the instantaneous power. And if you are going to find the average power, so average power for one cycle, this will be equal to 0, right? So the power absorbed in pure inductance is 0. So in purely inductive circuit, the power absorbed will be 0 here. Now next is AC circuit containing capacitance only. So if we talk about the circuit containing capacitance only, here the only capacitor is there. The voltage equation is Vm sin omega t, and if you find the value of current, here you can see this is omega t plus pi by 2. So plus pi by 2 means the current is leading the voltage by 90 degree. So now here the current will come and here the voltage will come. So voltage is lagging, right? The vertical position, the component which reach the vertical position first is the leading. So I, we have drawn, it is leading, but VC is lagging. So we have drawn VC here. It is lagging by 90 degree, right? So in a purely resistive circuit, the voltage and current, they both are in same phase, and in inductive circuit, the current lags by 90 degree, and in capacitive circuit, the current leads by 90 degree. Now again coming to the instantaneous power, the value is Vm by 2 sin omega t, and again if you are finding out the average power, so here you will get the 0. So in capacitive circuit also, the power absorbed is equal to 0. So in waveform also you can see, right? Here you can see the voltage, and here you can see that current is leading and voltage is lagging here. Now coming to the RL series AC circuit. So RL series AC circuit, here the circuit is drawn here, the R and L. We are talking about the series circuit, so R and L will be in series. The voltage drop across resistance is denoted with VR. The drop across this inductor is denoted with VL, and here this is the current. So if we talk about the relation with the voltage and current in resistance, we know that voltage and current, they both are in the same phase, and in inductor the current lags and voltage lead by 90 degree. So now if you want to draw the phasor, so here if you have taken, right, and the reference we have taken current, because current, it is common in both resistance and inductor, as this circuit is series circuit, right? So we have taken current as a reference. So if you have taken current as a reference, so if you want to draw the VR, if you want to draw this voltage VR, so where you will draw, you know that this VR, this is a drop across resistance, you know that this VR will be in same phase with the current. So you will draw VR here, right? You will draw VR here. Now you want to draw VL, right? You want to draw VL, and you know that this VL will lead the current. This VL will lead the current by 90 degree. So where you will draw? You will draw here. You will draw here VL. So this is leading, right? Leading by 90 degree. And the resultant of this will be equal to V. This you can denote with angle phi. So this is V, this V. So this V, basically this is a phasor sum of VR and VL. So you can easily from this phasor diagram, you can find V So you know how to V, you can write V is equal to under root VR square plus VL square. You can write this equation, right? Now next we will discuss about the apparent, true and reactive power. So this is a very important terms. So first is the apparent power. So apparent power, this is the total power that appears to be transferred between the source between the source and load, and this is equal to the product of the applied voltage and circuit current. So apparent power, this is denoted with capital S, and this can be written as V into I, and the unit is volt ampere. The unit is volt ampere. Now next is the true power. So this is the power which is actually consumed in the circuit. Actually consumed, right? What is true power? This is also called as the active power also. This is the actually consumed. This is the power which is actually consumed in the circuit. This is called the true power or active power, and it is measured in watts. So remember all these units. This is very important, and this is denoted with capital P, and this is equal to VI cos phi. Now next is the reactive power. The component of apparent power which is neither consumed nor does any useful work in the circuit is called reactive power, and it is measured in volt ampere reactive. It can be written as VAR. VAR, that is volt ampere reactive, and this is denoted with capital Q, which is equal to VI sin phi. So basically you can say that apparent power is equal to sum of true power and reactive power. So I am summarizing again this apparent power. This is denoted with capital S, which is equal to V into I. What is the unit? This is volt ampere. Then true power, this is denoted with capital P, and the unit is watts. And reactive power, this is denoted with capital Q, which is VI sin phi, and the unit is volt ampere reactive, which in short you can write VAR. So now here we can draw the power triangle. So power triangle, you can draw here the true power, you know, VI cos phi, so this will be on this axis. Then reactive power, this is VI sin phi, and the result of this is apparent power. So you can write apparent power, is equal to true power square plus reactive power square, right? Or you can write S square plus, you can write S square is equal to P square plus Q square, or you can write S is equal to under root P square plus Q square, right? So this is the relation between these three powers, and the power factor which is cos phi. So this cos phi is equal to true power by apparent power. So you know true power is VI cos phi by VI. So this is, you will get the power factor. Now we will take one example. So in this V equation is given 200 sin 377t volt, and the current equation is also given, and you have to determine the power factor, true power, apparent power and reactive power. So what is given? The given values are the voltage equation and the current equation. So from this voltage equation, if you see this voltage equation, if you compare this equation with Vm sin omega t, so here you can see that this 200 is nothing but the maximum value of the voltage. So this Vm is equal to 200. Similarly here, this is sin omega t minus phi. Here you can write Im sin, you can compare this equation with minus phi, sin omega t minus phi. So here you can see that the value of maximum current is equal to 8 ampere. So this is the given values in the question. Then from the maximum value you can find out the RMS value. Just divide this maximum value by under root 2. So here you can see we have divided 200 by under root 2. So this is the RMS value of voltage. Similarly, you can find the RMS value of the current. And for finding out the angle, here you can see no angle is mentioned here. So you can write, this is a polar form of writing, right? You know the polar form. Polar form means R angle, if your angle theta. So this is the polar form. You have written this voltage value in the polar form, and you can also write in the rectangular form, right? So this is 141, this value, and for current the angle is given here, that is 30 minus 30 degree. So the RMS in polar, and this point should be remembered. If you are writing the value in the polar form, means this R, so this R is always the RMS value. We always write here the RMS value, right? So if the equation is given in this form, so you know that this is the maximum value. So you will convert this maximum value into the RMS value. You just divide it by under root 2, and then you will get the RMS value. So you can write the voltage value in the form, in polar form. So always remember that this is always the RMS value, right? Here also this is the RMS value of the current, right? So now you have find out the value of V and I in the polar form. Now from here you want to find the power factor, that is cos phi. So here you know the angle which came given is 30 degree. So cos 30 degree, this will be lagging because the minus sign was there. Then the apparent power, we know that apparent power is V into I. So V into I, V value is this and I value is this, right? So V and I value is this. So if you multiply, you will get 800 volt ampere. You should always write the unit, right? And then true power is Vi cos phi. So Vi cos phi and the unit is watt. Then reactive power Vi sin phi, and by putting the value you will get 400 VAR, that is volt ampere reactive, right? So this is how you can find all these three power: apparent power, true power and reactive power, right? And you can also verify this as apparent power. We know apparent power, this is S, this is P and this is Q. Just you can calculate and verify by yourself by using this equation. S is equal to under root P square plus Q square, and if you put all these value, you will see that you will this value will satisfy this equations. Now coming to the RC series AC circuit. So here R and C, they are in series. Then here the V, you can write VR. Here you can draw the phasor diagram. You know VR and I are in same phase, and you know that VC voltage will lag the 90 degree, right? Lagging, you current you have taken as a reference because the current is the common in resistance also and in capacitance also. So that component you will take in take as a reference. So here you have taken the current as a reference. Then if you want to draw the VR, it will be in the same phase. Now you want to draw VC. Where you will draw VC? You know that current will be leading and voltage will be lagging. So here if you see, you have here in this we have drawn VC the downward, right? So if it rotate in the clockwise direction, you can see that this current will reach the vertical position first, and after this VC will reach, right? So it means you have drawn the correct phasor diagram. So current and here VC, because it is in downward direction, so this will be minus VC and the resultant will be V, right? So from this phasor diagram you can write VR square minus VC square. So by putting the value of VR, that is I into R, and VC means I into XC, XC means capacitive reactance, right? So after solving this, you will, and taking out this current as a common, you will get I into under root R square plus XC square. So here V is equal to equation this, so you can write I is equal to V upon this, and this R square plus XC square under root, this is nothing but the impedance, right? So this can be, this part you can write it as Z. Impedance we denote with capital Z. So you can write V upon Z, where Z is equal to under root R square plus XC square. So so this quantity, this is the impedance. Impedance means it is offering the, it offers the opposition to current flow, right? So here V upon Z, as I told you, you can replace this by Z. Then the phase angle, if you want to find the angle tan phi, you can write it as by, here we have drawn the impedance triangle. So impedance triangle, from this equation you can see this is R, this is minus XC, and Z. So Z is equal to under root R square plus XC square you will get, and from here you can write tan phi is equal to VC by VR, or you can write I in this form, and finally you will get minus XC by R. So this is how you can find the tan phi, or you can, if you want to find the value of phi here. Then RLC series AC circuit. Now coming to the RLC series AC circuit. So here we have R, here we have L, and here we have C. All these are now connected in series. So now if you, now how to draw the phasor diagram? Again the current will be taken as a reference. Then you know that this VR will be in same phase, and VL will lead and VC will lag. So VL and VC. So you will get the resultant of this VL. So you here it is written VL minus VC. So VL minus VC, you will get the resultant here. So from here, and this is the resultant V. So you can write VR square and VL minus VC square. So if you solve this, you will get this equation and this quantity, right? This quantity is again the impedance of the circuit. Impedance means it offers the opposition to the current flow. So from here you can find the cos phi, that is R by Z, and R by Z XL minus XC square. Now in this we have three cases, right? So here the equation I have written XL minus XC, but the first case XL may be greater than XC, right? So if XL is greater than XC, then phase angle will be positive and circuit will be inductive, right? If XL is greater, the circuit will be inductive, or we can say in such cases the circuit current I will lag behind the applied voltage V by 5, because if it is inductive, so the current will lag. Then the second case, XC is greater than XL, so the circuit will be capacitive, right? So here the current will lead the applied voltage by angle phi. Or the third case, that both XL and XC, they both are equal. So if they both are equal means they will cancel out each other, right? They will cancel out each other and the circuit will be purely resistive, or in other word we can say that the applied voltage will be in phase with the current. So phi will be 0 and the circuit will have a unity power factor, right? Because phi is equal to 0, so cos 0 is equal to 1, so power factor will be equal to 1. So for purely resistive circuit, the power factor is 1. So these three cases can become in series RLC circuit. So this is the summarized table of R, L and C circuit. So for pure R, L, C, then for RL, RC and series RLC. So in polar form, if you are writing the impedance in polar form, this will be R angle 0 degree or R plus J, or XL angle 90 degree, because this angle is basically angle between voltage and current, right? So we know that in inductive, V and I, the difference between V and I, the angle is 90 degree. Here we have minus 90. So you can write in JXL minus JXC. Here the real part is 0 and here the imaginary part is 0. Then series RL, you can write it as Z angle plus phi or R plus J XL. For in RC, angle will be in minus phi. So this is R minus JXC. This is in rectangular form. Similarly, from here you can find the phi power factor. Here you can write. Then this purely resistive have unity power factor. This is 0 power factor, lagging, you called it lagging, and 0 leading. If leading and lagging, it depends upon the current. If current is lagging, you say power factor is lagging. If current is leading, you say current power factor is leading. So you know that in inductive circuit the current is lagging, so the power factor will be lagging. In capacitive circuit, current is leading. Here I, this is leading, so here you will say it is leading. And again here, according to the if it is inductive, so lagging. If it is capacitive, it is leading. If it is equal, means circuit is purely resistive, it is unity. Now again we will take one example. So in this, a series RLC circuit is composed of 100 ohm resistance, then we have 100 ohm resistance, 1 Henry inductance and 5 microfarad capacitance, and voltage equation is given here. So you have to determine the current and the voltage VR, VL and VC. So this VR, VL and VC means voltage drop across resistance, inductance and capacitance, right? So here this is given, voltage equation is given, and you can compare this equation with the standard equation, that is Vm sin omega t. So now you know that this value is the maximum value. So from here you can get the maximum value, and the circuit, the quotient, according to quotient you can draw this circuit. You know, R is 100, L is 1 and this is 5 microfarad, and you have to find this VR, VL, VC, and you have to find the current, right? So how you will find, what will be the approach? So you know, first you will find the total impedance, right? So for finding out the total impedance, you know the value of omega, you can find the RMS value. So the polar form of the voltage is, you can write it in the polar form. Then you can find the total impedance. So total impedance will be R plus ZL plus ZC. So ZL will be JXL, ZC will be JXC. So after finding out this and putting all these value, you will get the total impedance. Now you know the total impedance and you know the total voltage. So you can find the total current, right? So I is equal to V upon ZT. So after solving this, you will get the value of total current. So now you know the value of total current. Now you have to find VR, VL, VC. VR is I into R, VL is I into ZL, VC is I into ZC. So just by putting the value and calculating, you can find out the value of VR, VL and VC, right? So these are the values. Now coming to the parallel AC circuit. So methods of solving parallel AC circuit, it could be solved by using Phasor Algebra method or admittance method, or you can also use the Phasor method also, right? By by Phasor Algebra, here the circuit is given. You can see that R and C and this R and L, they both are connected in parallel, right? So V, you have written, you can write in polar form, that is V angle 0 degree. Z1, here the total the total impedance of this branch, that is Z1, and total impedance of this branch will be equal to Z2. So Z1, you have written Z1 angle minus phi 1. Why minus phi 1? Because here we have capacitor. Then Z2, we have written Z2 angle phi 2, because here we have inductor, right? So this Z1 you can write it as R1 square plus XC square also, and for Z2 you can write it. So if you want to find the current in this branch I1, so I1 will be the as these both are in parallel, so voltage, the same voltage will be here and the same voltage will be here. So if you want to find the current in this branch, so I will be equal to this voltage divided by the total impedance of this circuit. So I1 is equal to V by Z1. So from here you can find this. Similarly, you can find the branch current of this branch, and here you have I1, here you have I2, and if you add this I1 and I2, you will get the total current. So here in AC circuit we do the phasor addition, right? Either you write in the rectangular form or in the polar form, and then you solve that equation. Now coming to the next method, that is admittance method. So what is admittance? It is basically reciprocal of the impedance, right? Impedance we denote with Z. So if you take the reciprocal of this impedance, you will get the admittance, and it is denoted with capital Y. And the unit of this admittance is Siemens, or we also write mho, MHO, right? So you can write mho also. Ohm you write like this, and mho you write like this, right? This is a symbol for mho. You can write this also, or you can write Siemens. This is the latest unit, and we denote it with capital S. So Z is the opposition to alternating current flow, and admittance is the inducement to alternating current flow. And this if you write the admittance, the 4 components are there, right? So component, they depend upon the nature of reactance, and the impedance of AC circuit can be expressed in complex form. So Z, this is Z is equal to R plus JXL, or Z is equal to R minus JXC, right? And if you take the reciprocal of this, means it will come 1 upon R. So 1 upon R is nothing but the conductance. We denote it with G, and 1 upon XL or 1 upon XC, this is susceptance, right? So they are 2 part, conductance and susceptance. Then if there is a R and L parallel circuit, this is the circuit, R and L, this is the parallel circuit, and here I1 current is flowing in and I2 is here. So total I will be V upon Z, I1 will be V upon R, I2 will be V upon JXL. So here we have rationalized it, and you get minus J V upon XL. So this total I will be equal to I1 plus I2, right? We are doing the phasor addition, right? So we are doing the phasor addition. So I1 plus I2, just put the value of I1 and I2 here, and after solving this, here we are getting this equation, right? 1 upon Z is equal to 1 upon R minus J 1 upon XL. So we are getting this equation. In this 1 upon Z, what is 1 upon Z? This 1 upon Z is nothing but this is equal to Y. The reciprocal of impedance will be written as Y. Now what is 1 upon R? This 1 upon R is nothing but this is G, that is conductance, right? And what is this 1 upon XL? This 1 upon XL is BL, that is susceptance. So we can write this Y is equal to, you can write this Y is equal to G minus J BL, right? Conductance and susceptance. So this is the equation of admittance. Similar manner you can find in RC parallel circuit. So RC parallel circuit, here the equation you will get G plus J BC. The procedure is same. Here you have written the total current, then you have find the I1, then you have find the I2, and then you have done the phasor addition. Just by putting the value, you will get Y is equal to G plus J BC, where J is conductance and B is susceptance, right? And this is BC is 1 upon XC. So for the inductive circuit, that is R plus JXL, this is the impedance, right? The impedance and admittance triangle, you can see here, this is the impedance triangle. And if you want to draw the admittance triangle, so it means you are taking the reciprocal. So in place of Z, you will get Y. In place of R, 1 upon R, you will get G, and XL 1 upon XL, you minus BL, right? So this is the admittance triangle. Again, similarly for the capacitive circuit, this is the impedance triangle and this is the admittance triangle, right? Then here we have taken one question, the resistance of 20 ohm and a coil of inductance 31.8 millihenry and a negligible resistance are connected in parallel across 230 volt 50 hertz supply. Find the line current, power factor and the power consumed by the circuit. So here in this question, you have to find the resistance of 20 ohm and a coil of inductance 31 millihenry and a negligible resistance. They are connected in parallel. Here in this circuit, here you can see the circuit is drawn like this. So you can find IR. IR means V upon R. V upon R. So you know the value of V and you know the value of R. It is given 20. So you can find the value of IR. You can find the value of XL because the value of L is given. So XL is 2 pi FL. Then easily you can find the value of IL, that is V upon XL, right? So you can solve this. So if you want to find this current is basically the phasor sum of IR and IL. So here you have written under root IR square plus IL square. So you can get the value of this current. Then you can find the value of cos phi, that is IR by R, and similarly you can find the power consumed, that is VI cos phi. So this is how you can find the power consumed. Now next is the 3 impedances are given, that is this is 70.7 and these are the 3 impedances, this one and this one, right? And they are connected in parallel across a 250 volt supply. You have to determine the admittance of the circuit and the supply current and the circuit power factor, right? So first we will draw the circuit. All these three impedances are connected in parallel, right? So just draw the circuit. So this is Z1, Z2 and Z3. So Z1 is this is Z1, this is Z2 and this is Z3, right? So this question this question was asked in AKGEC in 2021-22. So this is the circuit and the supply is 250 volt. This is 250 volt, right? So this is how you will draw the circuit. And now you have to find out the admittance. So how you will find the admittance? What you will do? The total admittance, right? So first you find the admittance of this. So admittance of this, that is Y1. Y1 will be equal to 1 upon Z1. Similarly, admittance of this, that is Y2. This is equal to 1 upon Z2. And admittance of this, that is Y3. This is equal to 1 upon Z3. So if you now you after doing 1 upon Z1, 1 upon Z2, 1 upon Z3, you will get the Y1, Y2 and Y3. So Y1, Y2, Y3, if you add all these, right, here I have done Y1, Y2 and Y3. If you add all this Y1, Y2 and Y3, you will get the value of total admittance. So this is the value of total admittance, right? Just simply adding this admittance value. So it is written in a rectangular form. Then you want to find the impedance. Now you have total admittance. So what you will do? You will just impedance will be equal to 1 upon admittance. So impedance will be equal to 1 upon admittance. So Z is equal to 1 upon Y, and this Y, you know the value of this Y, right? So if you solve this, you will get the value of total impedance. Then you have to find the power factor. So power factor is R upon Z. So by doing this, you will get the power factor. Now the next question is, two coil having resistance of 5 ohm and 10 ohm and inductance 0.04 and 0.05 Henry. They are in parallel across a 200 volt 50 hertz supply. Now you have to calculate the conductance, susceptance and admittance of each coil, right? So one coil means the resistance is here and inductor is here. Then resistance is here and inductor is here. So they are connected in parallel, and you have a supply of 200 volt 50 hertz. The frequency is given 50 hertz, right? So this is 5 ohm, this is 10 ohm, this is 0.04 ohm, this is 0.05, sorry, not ohm, this is Henry and this is Henry. So this is given. So you have to find the conductance. So first what you will find? You will find the impedance Z1. So Z1, what is Z? Z is equal to R plus J XL, right? So the value of XL is not given, but the value of L is given. So you know that XL is equal to omega L, right? And this omega is 2 pi f, and the frequency value is given 50 hertz. So you can simply find out the value of XL. So that is what it is. The resistance value is here. The resistance value is 5. It is written 5 here. J, 2 pi omega. This is 2 pi omega into 0.04 L. L value is 0.4 is given in question. So if you solve, you will get the value of Z1. Similarly, you can find the value of Z2. So now you have to tell the conductance and susceptance of each coil. So you will find the admittance here. So after finding out the admittance, that is 1 upon Z1. So if you do 1 upon Z1, you will get this value. So this 0.027 is nothing but this is the conductance, that is Z, and this value is nothing but this is the susceptance, that is B. So 0.27 will be the conductance and 0.068 will be the susceptance. Similarly, for next coil also you will do the same procedure and you can get the value of conductance and susceptance, right? Then you have to find out the current. So I you can write, you know that, sorry, I is equal to V upon Z, right? V upon Z. I am writing it again, V upon Z. So or you can write V into 1 upon Z. So this 1 upon Z can be replaced with Y. So it can be written as V into Y. So you know the total admittance, you can find out the total admittance because you know Y1 and Y2. So total admittance, so you can find out the current value by using this equation. So this is the total current. So from here you can find out the power factor, as angle is coming 63.75. So this is the power factor. Then power absorbed, VI cos phi, you know the value of V, you know the value of I, that is 25.4. And this V and I are the RMS value. So for polar representation, you can get the RMS value. So you will get the power absorbed for this circuit. So for this lecture, I have taken the references. I have referred this book and I have referred the AKTU previous question. Thank you. Jai Hind.